All right, we're in the section 21 now. That's the materials for exercise 21. So it's really kind of designed to get you to do exercise 21. And the structure is going to be the same each and every section we get to. So, for example, there'll be contents. That's where Wells will walk you through the material. There'll be examples. That's where I'm going to, walk you through the material and actually work at the whiteboard for you. And then there's exercises that you need to work on. Now, this document is being prepared for the prison mathematics project. All right. Now, what I mean by the participants, that means the incarcerated, the administrators, prison security, they have access to the document. But I realize that other people may want access to the document. Now, in my original, not original, but the initial videos that I presented to you, I told you how to get the actual text. Not this, though. This will be published later. It'll be about 3,000 pages long. But it'll be published later. If you need to reach out, though, just, inquiring about when that's going to happen, or, you can email me if you want. That's my email address, b as in boy, @nnon.us. Like each section, something's being introduced. What's being introduced over here? Well, it says solution equation by factoring. Certainly Wells presents material in a very reasonable way. I'm not saying otherwise. But I'll be honest with you, like for a modern teacher, they probably wouldn't present it this way. And really what he's presenting is what's called a zero product rule. What does that say? It says if you have a factor like a times b, I'll write this down for you, it should seem reasonable to you if the product is equal 0, that a is 0 or b is 0. And this could be extended to any number of factors. For example, if I do a times b times c equals 0, you should have some idea that a is 0 or b is 0 or c is 0. So he kind of talks through that. He does some examples. You may not appreciate the way he does things, but that's incidental to me. You may not appreciate the way I do things. You'd have to reason through this stuff on your own to get there. So my goal over here is to, talk about how I would want you to do the problems. And I'm using what's called, and I'll write it down again for you, I'm using the zero product rule. Now, again, you would need to know what that rule is stating. It's saying if I have a product equal to 0, what am I basically saying? A is 0 or B is 0. And this could be extended to other number of factors besides 2 factors, 3 factors, 4 factors, so forth and so on. So looking at problem number 1, what I notice, I do have the 0, but I don't have a product. So my first goal over here is to factor it. And the way I do that is what's called a GCF. So I'm going to say x times 2x minus 1 equals 0. First thing I would do, I'd set x equal to 0. That's the first factor. Or, that's like the big A. Or 2x minus 1 equals 0. Now, this one's clear to me. But this one's, well, maybe it is clear to you. I don't know. So I'm going to solve that. 2x equals 1, x equals 1/2. So I'm going to write my answer down now. My answer is going to be x equals 0 or x equals 1/2. All right, look at the key. Make sure you're staring at that. And we are. We're seeing this right over here. Okay? Let's go to the next one. I'm sorry. I forgot. I didn't circle everything. I apologize. I have to erase it. Let me just circle that for you. This, whoops, x equals 0 or x equals 1/2. All right? Let's keep going. Let's look at number 2. Now, number 2, it's a cubic, right? So I'm expecting to see 3 factors. And I'm hoping it's reasonable. I'm hoping it's not so difficult I can't factor that. Now, could it be difficult? Yeah, it could be. But I don't think so. Let's take a look at it. I'm going to try to factor by grouping. What does that mean? Take the first 2 and last 2 and factor those groups. So the first group, which is x cubed plus 4x squared, x squared would come out. And what are you left off with? X plus 4. Now, I'm going to factor out minus 1. And what do you get? X plus 4. The next thing I do is look at those 2 terms and factor out the common factor, which is x plus 4. What are you left off with? X squared minus 1. What's the next thing I'm going to do? I'm going to factor the difference of perfect squares. You get x plus 4, x minus 1, x plus 1 equals 0. Now I got three factors, all right? So it's like a times b times c equals 0. Well, what do I know about this? X plus 4 equals 0, or x minus 1 equals 0, or x plus 1 equals 0. So what do you get over here? X equals minus 4, or x equals 1, or x equals minus 1. I'll put a box on that. Of course, some questions I got the right answer. I do want to point out you're looking at those answers over here. All right? Let's go to the next question. And Wells is, kind of, I'm going to say famous for doing this. He writes problems that you might get horribly confused by. No doubt about it. Horribly confused by it. All right, so what I want to do is, I'm looking at it, and I don't want to expand it, but I'm thinking that my past in factorization might help me. But I just don't see the 0. Right, now someone says, I want to get to 0. I'm not going to deny it. We can do that. But what I'm going to do right now is I'm going to look at it, and I notice that this side over here is the sum of perfect cubes. And I know what that looks like, but let me write this down for you. And again, I'm not saying it's going to work for us. I just want to see if I can do something here. And let me write that down for you. So that would be x minus 1 plus x minus 2. Let me read what we're doing. We're doing a cubed plus b cubed. This is from prior sections. That's going to be a plus b times a squared minus ab plus b squared. And that comes from a prior chapter. Let's do, dot x minus 1 squared minus x minus 1, x minus 2, plus x minus 2 squared. Now, I realize for some students, they're saying, this is crazy. Where's this ever going to end? He's not writing problems that don't work. I kid you not. He's not writing problems that don't work. But let me keep going. I know it looks difficult, and I got to squeeze this in now. 2x minus 3 cubed equals, well, I want to do this now. And what do you get? 2x minus 3. All right, let's do the other one. I know it's difficult, but I want to point out to you. X minus 1 squared is going to be x squared minus 2x plus 1. Now, I want to do this, but I realize it's going to be a subtraction problem. So before I do subtraction, I want to point out this is x squared minus 3x plus 2. So I'm going to subtract it. What do you get? Minus x squared plus 3x, right, minus 2. Let's do the next one. What's it going to be? I got to do this one now. Now, what does that give you? So an addition, so it's going to be easy to do. It's going to be x squared, right? And then what do you get? Minus 4x plus 4. Let's combine together. And it really doesn't look that bad to do. What do I get? I'd get x squared. Right, that's not so bad, right? And then what do you get for the middle term? Let's see. Looks like you get minus 3x, right? And then what do you get? You get 4 minus 2, which is 2. You get 3. All right? So someone says, well, all that work, I don't even know why I did it. Well, part of the reason you did it was just to figure out if you could get this done. And I think we're getting kind of close to it. All right, I know it might seem difficult to you. I think we're getting close. So I got this over here, and so it was a lot of work to get there. And what I want to do is, I kind of want to get it to the 0 now. And I'm going to put that down for you. All right? So 2x minus 3 cubed minus 2x minus 3 x squared minus 3x plus 3 equals 0. So I took this thing and I rewrote it by subtracting that really crazy looking term from both sides. Now, what do you notice about these two terms? They have a common factor. And I'll write that down. Again, I'm not saying it's easy. I'm saying it's doable. So you get 2x minus 3 And this is Wells for you. He really writes problems that require work. We left off with 2x minus 3 squared. But if you do the work, there's a payout. It's going to work. Minus x squared, the quantity x squared, minus 3x plus 3. And, it's still more work. Let's write this down. 2x minus 3. Now, I got to do what's on the inside there. And that looks like a lot of work, right? So I'm going to point out what I'm doing over here. I'm going to do this first. And let's write that down for you. That would give me, and this is side work for me, it's a lot of side work, 4x squared minus 12x plus 9. And then what we're going to do is we're going to subtract away this thing. And let's write that down now. So that would be minus x squared plus 3x minus 3. And what are you going to get? Let's take a look. You would get 3x squared minus 9x plus 6. All right, I got problems now. Someone said, I wonder what your problems are. I still have to factor. I got a square. And I'm looking at this over here. And let me point out what I'm looking at. I'm looking at this now. Now, by the way, if this doesn't work out, you can pretty much assume you've done something wrong because Wells is not asking questions you can't do. So I'm going to write this down for you. You would get 2x minus 3. And what factor factors out from those three terms? A 3. That's called the GCF, by the way. What do you get? X squared minus 3x plus 2. I'm going to continue to factor. I'm going to put down 3, 2x minus 3. And now I'm going to factor, and I'll point out what I'm factoring, this guy over here now. I think it's doable. I think if it's not doable, I must have made a mistake somewhere. So I'm going to say x and x. And yes, I notice a lot of work. 2 and 1, minus, minus. I'm using trial and error, by the way. It works beautifully. What am I going to do? Set the factors equal to 0. I hope you don't ever believe that 3... Whoops, sorry about that. I hope you never believe 3 is 0. It's always 3. But this guy is going to be 0 somewhere. This guy will be 0 somewhere. And this guy will be 0 somewhere. Let me write those down for you. 2x minus 3 equals 0. This would mean x equals 3 over 2. The other one is x minus 1 equals 0. When does that occur? When x is equal to 1. What's the last one going to be? X minus 2 equals 0. When does that occur? When x equals 2. Let me just put a circle on this. And I'm going to say that's my answers. Let's just check them out. And I'm seeing those over here. All right, 3 halves, 2, and 1. They worked out beautifully. All right, now someone says, wait, that's a lot of work. I'd like to do it a little bit differently than you do it. And there's no reason not to do it differently than me. But this is the way I would approach it. Now, someone's going to say, oh, your work looks a little bit different than this scratch work over here. But I got to be honest with you, it's time and time again what I'm doing. I'm putting like scratchy work down. This is, all that scratchy work. But I really need to type it up. And that's what the whole thing is over here. And that's not bad to look at it if you're struggling. Like if you're doing your scratchy work and you're not getting the right answers, look at my work. Look at my typed up work. Don't look at this chicken scratch. But my chicken scratch leads to the same thing, by the way. And by the way, that's exactly how I solve these problems when I'm doing them. I take a piece of paper out, I do scratch work, and then I type it up. Or I try to make it neat when I type it up, by the way, so it's readable. All right, so what happens now? There's exercises. Someone says, I wonder if the exercises are just like the examples they've given me. Wells is good at that. He really does give examples that are similar. So these exercises are going to be similar to what we just did, but sometimes he challenges you. I mean, sometimes they're really simple. Sometimes he's going to challenge you. But the bottom line is, it's good to be challenged. You want to work through this stuff and get challenged. You don't want to say, oh, gee, this is easy, 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 easy. You need to get challenged. We want to challenge you. So look through the work. And I know there's a lot of problems over there. Someone says it's way too much. You decide what you need to do. But I'll say this, the more exercise you do, the better you're going to get at doing problems like this. All right? Furthermore, when you study math, it goes beyond this. Like when you get to trigonometry and calculus, it'll be a lot easier for you. I'm not going to say you sail for those courses, but you'll be much better able to handle the material they're throwing at you. So again, there's a lot of problems, right? And then you get to the SAGE stuff. Again, I know it sounds like a broken record to you, But what's Sage? It's a computer algebra system. It's free. I like that idea. It's really not free. When I mean it's free, it's open source software. But a lot of people work on it, man. They put a lot of time into it. You can download it as an application to your computer or use an interactive web-based application. What we're trying to get you to do is just look at code, right? Look at code, look at the outcome of the code, and see why it's useful. See why these problems are really trivial to a computer. But let me say this again. The people that code this stuff know algebra. They could not have coded it otherwise. All right, so next time we come back, we'll take care of it, okay? Bye-bye.